Hello guys, we Adarsh Kumar, Priyadarshan and Aman Singh of group 7 and 8 are representing before you use of bipolar junction transistor as a switch. So here we begin now. Because we know a transistor's collector current is proportionally limited by its base current, it can be used as a sort of current controlled switch. A relatively small flow of electrons sent through the base of the transistor has the ability to exert control over a much larger flow of electrons through the collector. Suppose we had a lamp that we wanted to turn on and off by a switch. Such a circuit would be extremely simple as given in figure A, as we are showing you on the screen. Now, for the sake of illustration, let's insert a transistor in place of a switch to show how it can control the flow of electrons through the lamp. Remember that the controlled current through the transistor must go between the collector and the emitter. Since it is the current through the lamp that we want to control, we must position the collector and the emitter of our transistor where the two contacts of switch were. We must also make sure that lamp's current will move against the direction of emitter arrow symbol to ensure that the transistor's junction bias will be correct, as in figure B, as we are showing you.
Could also have been chosen for the job. Its application is shown in figure above C. The choice between NPN and PNP is really arbitrary. All that matters is that the proper current directions are maintained for the sake of correct junction biasing. Electron flow going against the transistor symbol's arrow. Going back to the NPN transistor in our example circuit, we are faced with the need to add something more so that we can have base current. Without a connection to the base wire of the transistor, base current will be zero and the transistor cannot turn on, resulting in a lamp that is always off. Remember that for an NPN transistor, base current must consist of electrons flowing from emitter to base against the emitter arrow symbol, just like the lamp current. Perhaps the simplest thing to do would be to connect a switch between the base and the collector wires of the transistor as shown in the figure below.
If the figure is open as in figure above, the base wire of the transistor will be left floating and there will be no current through it. In this state, the transistor is said to be cut off. If the switch is closed as in figure B, electrons will be able to flow from the emitter through the base of the transistor through the switch up to the left side of the lamp, back to the positive side of the battery. This base current will enable a much larger flow of electrons from the emitter through to the collector, thus lighting up the lamp. In this state, maximum circuit current, the transistor is said to be saturated. Of course, it may seem pointless to use transistor in this capacity to control the lamp. After all, we are still using a switch in the circuit, aren't we? If we are still using a switch to control the lamp, if only indirectly, then what's the point of having transistor to control the current? Why not just go back to our original circuit and use the switch directly to control the lamp current? 2 points can be made out of this. Actually, first is the fact that when used in this manner, the switch contact need only handle what little base current is necessary to turn the transistor on. The transistor itself handles most of the lamp's current. This may be an important advantage if the switch has low current rating. A small switch may be used to control a relatively high current load. More importantly, the current controlling behavior of the transistor enables us to use something completely different to turn the lamp on or off. Consider figure below, where a pair of solar cells provides 1 volt to overcome the 0.7 volt, that is the voltage between base and emitter of the transistor, to cause base current flow, which in turn controls the lamp. Or we could use a thermocouple to provide the necessary base current to turn the transistor on in the figure below. Even a microphone with enough voltage and current output could turn the transistor on provided its output is rectified from AC to DC, so that the emitter base PN junction within the transistor is always be forward biased. The point should be quite apparent by now. Any sufficient source of DC current may be used to turn the transistor on, and that source of the current only need to be fraction of the current needed to energize the lamp. Here we see the transistor functioning not only as a switch but as a true amplifier, using a relatively low power signal to control the relative large amount of power. Please note that the actual power for lighting up the lamp comes from the battery to the right of the schematic diagram we shown you earlier. It is not as though the small signal current from the solar cell, thermocouple or microphone is being magically transformed into a greater amount of power. Rather, those small power sources are simply controlling the battery's power to light up the lamp. We had discussed about the BJT as a switch. I hope you all understood and enjoyed it. Thank you.